Hello everyone. So we'll start today's webinar about solutions for alternative weed control. This is the fifth webinar on this topic. And today is a collaboration between OPER8 and GOOD project, which are both European projects focusing on weeds management. So today's focus will be on cultural control solutions. I will just present you the program of the day. So we'll have a short introduction about the two projects by Olga Kriesi and Alexandros Tataridas about the aim and tasks of the two projects for weed control. And then we will focus on living mulches for arable by Matt Smee from the Organic Research Center, UK, and Exogenous, dead mulches for vineyards by Fanny Pressman from the French Wine and Vine Institute in France. Then we will switch to cover cropping systems with the combined effect of cover cropping and agroecological weed management treatments for wheat and grapes by Yannis Gazoulis from the University of Athens in Greece. And we will finish with seed inoculation to improve cover crop performance in conventional and organic farming systems by Maria Ramos from CCText in Spain. So each presentation will be about 15 minutes, and you will have sometimes after each presentation about 5 minutes to ask some questions. So for the questions, you have on the top corner, right corner of your screen, question mark where you can click and you can write your question, and we will read the question out loud for the presenter, for the speaker who will answer your question. So feel free to write it whenever you have your question, and we will read it after each presentation and even in the end if there are many questions. This presentation will be recorded and will be available online afterwards on YouTube for OPER8, for IFV, and probably for Good Project too. So I will now hand over to Olga from OPER8, who will start presenting the projects. Thank you.
Hello everyone, let me share my presentation first. Great. So my name is Olga Kriesi. I'm a PhD candidate at Agricultural University of Athens and the project manager of OPER8. And thank you everyone for participating. And actually it is an honor for us that we are collaborating with another successful Horizon Europe project, which is good. So I hope you gain something from our webinar. I will tell you a few words about OPER8. We have 30 partners, 8 operational groups, which are farmer teams across Europe, and we are in 7 countries. Our main objective is to build a self-sustainable multi-actor EU-wide thematic network. What we do is we are basing our knowledge to the operational groups. We are supporting and promoting the solutions that they have found and, in general, alternative weed control solutions. Our operational groups are in France and Italy with cover crops, Spain with new biocides based on natural oils. In Latvia, they have a robotic laser. In Sweden, they're using drones. In Greece and UK, we have camera-guided mechanical weeding, and another solution in the UK, which is the electrical weeder. Our concept is that we build 7 national networks. We gathered the needs and barriers of farmers and that hinder their adoption of alternative weed control solutions. We find every possible solutions and we evaluate them to pick our best practices. Also, we have a digital inventory where we store all the solutions we have found, and coming soon, we will have the best practices that we chose for each country. Our methodology is that we created national action plans based on the needs of the farmers, and we have picked several solutions. Then, after 2 rounds of workshops, both national and on a European level, we have picked for each national network, so each country, their best practices. And for that, in the whole thematic network of OPER8, we will have 100 practice abstracts, 80 fact sheets, and 50 videos for everyone to learn and get to know alternative weed control solutions. Part of our results is this webinar. Our cross-fertilization activities. Our goal again is to disseminate and to let everyone know and how to use alternative weed control. Thank you so much, and I hope you have a nice webinar.
Hi everyone, good morning. My name is Alexandros Tataridas. I am a researcher at the University of Coimbra in Portugal. Just give me a second to share my screen. Can you see it in full screen?
Yes.
Right, thank you. So we are very happy to collaborate with OPER8 today, a sister project for us. And we are 20 partners. We operate in 11 countries across Europe. We have 16 living labs, and we are testing different agroecological weed management practices in annual and permanent crops, in conventional and organic slash mixed farming systems. Our main focus is to combine cover crops with different agroecological weed management strategies, and the purpose is to reduce the weed pressure and the herbicide input in our European farming systems. As outputs of the project, we have already available online an agroecological weed management repository where you can find practices about agroecology, and you can use them, you can give them to the farmers, and you can even use them for educational purposes. Now we are building a training module on agroecology and agroecological weed management, and at the end of the project, we will have a decision support system, which will be called the AWM Toolbox, which will propose, will recommend the combination of cover crops with different practices. Throughout all these processes, we are doing sustainability assessments, and we will produce business models and policy recommendations. Our objective is to encourage the long-term and large-scale transition to sustainable biodiversity-based agri-food systems through the development of the first agroecological weed management network. That's why we collaborate with OPER8 and other projects, and we welcome you to be part of the agroecological weed management network. You can see our methodology in order to achieve our objectives, and we center our methodology and ideology, let's say, in co-creation with people. So we have research and innovation activities. We try to digitalize our practices, assess and evaluate everything in this loop, and scale up our solutions to become practical for people. These are our innovations. You will hear more later by the two presenters from the GOOD project. But basically, we are using native mycorrhiza as a pre-sowing seed coating of cover crops in order to improve the cover crop competitiveness and ultimately reduce the weed pressure. And the second one is the use of drones in order to create weed distribution maps and prioritize actions, because agroecological weed management brings ecological concepts into the management of weeds. So our general impact is to advance sustainable and resilient farming systems. So we test, evaluate, demonstrate, and promote innovative combinations of practices, centering people by co-creating with them. You can follow our social media and check our website, which is continuously updated, and we will be very happy to cluster with you in our living labs or even in other activities across Europe. Thank you so much.
Welcome everyone. Can you see my screen on full display there?
Yeah.
Great. Welcome. My name is Matt Smee. I work for the Organic Research Centre in the UK, where I'm head of agroecology. Agroecology is a free knowledge exchange platform that is for farmers to provide information on regenerative, agroecological and sustainable farming practices. Today I'm going to be speaking to you about living mulch systems for arable production and the weed control options that they present. I'll begin by giving a quick overview of some field trial results that came from research into living mulch systems, and then we'll dive into the step-by-step process that farmers go through to implement this innovative system. So before we get started, what exactly are living mulches? Living mulches are semi-permanent legume understories that are undersown into cereals in year one. It's a very common practice, but it's really in year two that we're into what we call the true mulch year, where the established mulch has another cereal crop direct drilled into it. Living mulches sit at this cross section of traditional farming practices, such as intercropping, undersowing, cover cropping, and mulching. So just to quickly go through some research results, some of the science behind the practice. Trials were carried out over several years in the UK by the Organic Research Centre, Innovative Farmers, and Organic Arable. These are just a few of the headlines. So chart one, you can see that available nitrogen is found to be higher in living mulch systems compared with control after 2 years. This is really to be expected because the legume ley will do this, and it's building fertility in the system, and it may offer options for reduced inputs in sort of subsequent years. Chart two demonstrates the yields, clearly a significant element in all production-based systems. What we saw is with this chart, modern wheat varieties that were grown in living mulch systems suffered from a yield penalty of around 26%. This is a significant challenge presented in living mulch systems. However, it's not all bad news because there are cost savings made by using this approach, and significantly, the choice of cereals gives different results. So wheat is almost one of the worst case scenarios, but crops such as oats have proven better due to less root competition with the living mulch. But also rye has shown yield penalties of as little as 8%. This is due to its vigour and its ability to suppress the mulch in that second true year of living mulches. Another significant factor related to yield penalty with living mulches is how you view it across the whole rotation. In organic systems, where often a 2-year fertility building ley is used, some farmers are using the first year of that fertility building ley to act as a true living mulch. So they're getting an extra cereal crop within their rotation. If you view the practice from a whole farm approach and not just in a single year of isolation, these yield penalties can be mitigated by the management strategies that farmers adopt. Most significantly for this webinar is chart 3 and 4. So chart 3 shows that there was significantly lower weed burden in living mulches in year 2 versus the control. However, it's really important to highlight, and this is shown in chart 4, that the relative abundance of weed populations shifts towards a perennial weed burden in living mulch systems. And it highlights really the importance of managing perennial weed populations elsewhere in the rotation, and that adopting a living mulch system at a time in the rotation where perennial weed burdens are not too high. Looking at soil structure in chart 5, using the visual evaluation of soil structure tests where 1 is good and 4 is poor. After 2 years of a living mulch system, the soil structure was seen to be improved in the living mulch system versus a control. Chart 6 shows also that earthworm abundance is significantly higher under living mulch systems than it is in a control. Part of this can be put down to the fact that we are going to a no-till system in that second year, and studies show that earthworm abundance does rise. However, the clover ley used in this system seem to give additional benefit to the earthworm abundance figures. It's not all good news here. If we look at gastropod abundance in chart 7, it shows that in the autumn months, their populations are significantly higher in living mulch systems compared with a control. And this poses a risk to certain cereal crops such as rye that are susceptible to slug damage. Chart shows that overall insect diversity was higher in living mulch systems compared to a control in the autumn months when using the Simpson's index. So Quickly looking at those results, you can see that things are a bit mixed when it comes to using living mulches. And what we're seeing is that there are risks to the effectiveness of adopting this system, and they need to be managed by looking at the actions, considerations, and risks at each stage of the process. What I'm going to run through now are the various stages of a living mulch system and highlight these key actions, considerations, and risks that farmers need to understand to mitigate against potential failure of the system. There's an awful lot to go through, so I'm going to sort of run through it fairly quickly. But don't worry, we've just launched a farmer's guide into living mulches, and that will be, you'll be able to use that to plug the gaps of what I've run over here. So there's multiple approaches to using living mulch systems. What we're presenting here is a 3-year structure that can be adjusted for farmers depending on their conditions, the crops they use, and their rotations. This framework is a distillation of multiple farmers' systems and approaches that were used in various trials. So if we're looking at spring, year 1, this is where it all gets going. And ultimately, there's no difference in this year for how you would cultivate the land. It's a ploughed system. What's important here is the cultivar selection of your cereal. If you choose something like rye in year 1, its height and vigor has the ability to shade out the undersowing. So it's really important to choose something that has an upright habit. Often we see at this stage of the process, wheat is a very good process. No need to change your seed rates, no need to change your row spacings on this system. What is critical at this stage, and it really relates to the success of the whole system, is the living mulch species selection. There's a few different options. Often we see clover being chosen, and the trials we used a 2-leaf clover mix. You're looking for a small leaf clover or a wild leaf clover. The cultivars in the UK are Aber8 and Aber Herald, and this is undersown at a rate of 7.5 kilos a hectare. Something like red clover can cause problems in the second year, but due to its vigor. And even using a white clover mix, choosing it at this stage, you need to consider the root competition that's going to happen between the crop and the living mulch. Lucerne is quite often used in some systems, and that can be established actually in winter with something like an oilseed rape. But due to its vigor in the second year, it's not suitable for low input and organic systems because it can swamp the crop because you can't manage that growth of lucerne. So quite a few different options. The sowing rates need to be really trialed on each farm to demonstrate what's best for those individual farmers. And in a low input or organic system, the timings for sowing that living mulch are going to be just around the time of the last harrow. So you can harrow the weed seeds out. That will create a nice tilth, and then you can overseed with an air seeder and a Cambridge, what we call a Cambridge roller in the UK. You can see that in one of the bottom pictures there, and that just compresses the soil, and any moisture there helps with germination. What's really important is in a very dry spring, you need to be able to sort of really sow when you've got some rain expected, because if there's no rain and the soil's a bit moist, that living mulch will establish, but then it'll die off fairly quickly. So timing is really critical on that. If we're looking at the summer management in year 1, there's not much really that you can do any different to a normal system. In a conventional system, you may be considering applying nitrogen to give the crop a bit of a boost that's fine. In something like organic systems, really you might be just only looking at something like a digestate. What you're looking for as the sort of summer season progresses is for the living mulch seeds to germinate, and then as the cereal crop grows up, this will sort of shade it out, and the living mulch will sort of stop establishing. But by the end of the season, you will have enough of an established living mulch underneath that you can go into the second year into this true mulch. A couple of things to note at harvest in year 1. The yield penalty is you don't really see a yield penalty at this stage because the living mulch is generally that small that it doesn't create this crop mulch competition that we see in the second year. The only things to flag is that if you have a very well established mulch in the first year, some admixture can get into the grain tank, which can make grain cleaning a little bit harder. And if you're making straw, if you don't harvest the straw immediately and it gets wet, for example, you may find if you need to move it, some of that established living mulch can get pulled into the swath. But really, this is more of a problem in the second year. Year two, which is we're talking about the sort of really critical, the true mulch stage of the whole process. What's absolutely critical, once you've got your living mulch, it's established, you've got a good sort of good cover. You may graze that back a little bit before sowing, but the cash crop selection in this second year is absolutely critical. We've seen crops like wheat can suffer from a bad yield penalty, particularly with modern cultivars. This is because they're just not competitive enough, and there's not enough root complementarity between in the root zones, so you've got real competition there. Something like oats, as I said earlier, has shown to have a bit of a lower yield penalty, and not quite as a bigger impact on reduced tillering levels. But rye really is where we're seeing the biggest the smallest gap in yield penalty, and that's because of its vigor and height. What you want to consider from a direct drilling perspective is your timing. You're going to probably graze or flail mow the mulch before you sow so that you've knocked it back as much as you can. Disc or tine drills will work perfectly well. Your seeding, your widths, they can be absolutely standard, as you would normally do, but you may want to consider a 20 to 50% increase in seed rate when you're sowing. This is to combat the mulch crop competition, and it helps to mitigate against reduced tillering in those cereal crops. As we go into winter, there's quite a key action that affects us around this time of year in the UK. Once the cereal is established, and it goes sort of into dormancy along with the mulch, you need to graze or flail back the mulch. This can be done anytime up to stem extension of that cereal crop, and in the UK that happens around sort of middle of March time, depending on weather conditions. And what happens is there's a few week difference between the cereal waking up and getting going again than there is the mulch, and you want that mulch to be as low as it can be while it's dormant so that the cereal crop can get away and really start to grow and outcompete the mulch. Looking at spring, this is where you start to see the yield penalty getting locked in. Reduced tillering sort of around this time of year happens due to mulch cash crop competition, and you will start to know, you can estimate from tillering counts what your yield penalty might be. So again, it goes back to that direct drilling time in in autumn of year two, when you need to choose the right cereal to manage. Right cereal selection to go with the mulch. At this stage, weed management, there's not much you can do apart from sort of use a weed comb to sort of collect seed heads. And you'll start to see potentially this balance of perennial weeds taking over a little bit if you've adopted this in a system where the weed burden is quite high from a perennial basis. But your annual weed burdens at this time will be very, very low, as long as you've got a good mulch with good cover. Harvest in year two, this is where there can be some problems. Yield penalty, you will obviously see it at this stage. And again, it goes back to what was your living mulch selection in year one and what was your cereal cash crop selection in year two. And again, I'd recommend trialing different seeding rates of mulch, different varieties of mulch, and different seeding rates and varieties of cash crop before you adopt this system on a broad scale, because that yield penalty can be a significant risk. At this stage, the living mulch will be quite high, and you need to adjust the boom height on your harvester to make sure you're not bringing too much of the mulch into the crop, because again, it can increase the grain cleaning costs and difficulty of that, but also it can affect when you're making straw and having green matter in that straw when you harvest it. You'll really see the difference of perennial weeds at this stage, and you need to assess those because that will affect your decisions at the next step. And also, you will really have a great opportunity to graze immediately after, reducing the need for bought-in feeds within a livestock. You'll also be able to check your soil health metrics at this time as well and see where those soil health indicators have been improved. Year three, this really depends on the system you've got and how you've adopted it. A lot of farmers at this stage in low input systems have quite a significant perennial weed burden, so they transition into a diverse lay. This is just done by overseeding, sort of what we call stitching in the UK. So if you have a clover-based lay, then you want some sort of herbs and vigorous grasses to be sort of stitched into that, and then you can go into a fertility building period that can be grazed. Some farmers, where the weed burden is low and the mulch is strong, they could consider going into another direct drilled cereal crop, but that really depends upon the system and particularly the weed burden at this time. So that is a very quick overview of of the living mulch system. I just wanted to flag that what we've got is this living mulch technical guide has been launched on the Agroecology website. I'll put a link to it in the chat. You can also use this QR code to get to it. It's a very comprehensive guide. It holds a case study of as well as a farmer, so you can see how they've approached it on their individual farm and the challenges they've had over the years. And to go with it, we've created a living mulch hub, and that sort of collates all the farmer facing resources, some research papers, videos, webinars that are on living mulches. So if you really want to dive into that a bit more beyond the guide, there's lots of information there for you. Just one last thing to highlight, we are working on a new project. It's a partnership between ADAS, Agravast, based in Sweden, and us, the Organic Research Centre. It's looking at companion cropping in oilseed rapes. Over the next 3 years, we'll be looking at evaluating companion cropping strategies and assessing how these different companion crop species and mixtures compete to influence pest, weed and disease management in oilseed rape. So really, it's the first stage of a living mulch. It's this kind of year one undersowing element of it. Along with that, we'll establish a farmer-led discussion group in the UK to enable peer-to-peer learning, and we'll be doing wider dissemination of sort of IPM success based on this system to support low input and organic protection systems. That's it from me. Does anyone have any questions?
Thank you very much, Matt. We have one question here. How can you have the mulch grazed in winter while the cereal grows right next to it?
Yeah, so it's absolutely fine. This is in a UK system. If you're drilling in, say, September or October, by the time you get to December, the cereal will be grown, and it will maybe be sort of this high. You can, as long as you move the sheep on and you graze them in sort of a mob grazing way, you can graze right down, and actually it supports reduced disease and it supports improved tillering as well, this process. There's a few, if you look at the living mulch guide that I'll put into the chat, there's a couple of references to studies that show improved tillering from grazing on cereal crops. It's quite a common practice in the UK, but you do need to manage the livestock if you're using livestock to graze so that they are moved on from the crop. There's lots of imagery in that living mulch guide, and you can see the comparison of what has been grazed versus what hasn't, and they're grazing really quite hard. As you get into sort of February time in the UK, that cereal starts to wake up again, and that's when you move the sheep on. The cereal grows away, and then the mulch remains dormant for a little bit, and it's a really important part of the process. So there's really no problem with grazing, but it definitely depends on timing, and it depends on your system. If you don't have access to livestock, you can do this with a flail mower as well, and that you can do that once or twice across the season.
Thank you. That's it for now. Might have other questions coming later. We'll carry on with Fanny now.
Hello, everybody. Yeah, I share my screen. Yeah, okay. So my name is Fanny Presman. I'm working at the French Institute of Vin and Wine. I'm doing research on alternative to herbicides and weed management. And I am also working on soil quality. I am going to present you this morning some results of trial on exogenous mulches for weed control that will lead for 4 or 5 years. So what were the objectives? The objectives were to acquire new references on mulching practices in the Occitanie region, because I'm located in Occitanie, close to Toulouse, in the objective to control weeds under the vine row, to try to find an alternative to herbicides, and also to mechanical weedings, because mechanical weeding can have some disadvantage. The objective of the trial was to evaluate the effectiveness of different materials. Several materials can be used for mulch. They have several efficacy. The objective was also to assess the benefits of the mulch on the soil structure and soil quality, assess the maintenance of viticultural performance, and evaluate the economic aspects of this type of mulch. So we have conducted several trials in a network of plots since 2020, and we have tested several materials, as you can see in this slide. So we have tested chestnut wood chip, miscanthus straw, softwood bark, softwood wood chips, and with addition of crushed vine shoots. We have also tested poplar wood chips, and we have tested some more original alternative like crushed oyster shells, wool, green waste that are composted only 1 month, Dittrichia viscosa straw, and after we have tested the several type of felt. So we have the cellulose felt and the lignin felt. So the two are felt, but they are from different material. And we have also tested bio-based plastic from maize. And all of these mulches were compared either with chemical herbicide or with mechanical weeding. So this is some pictures at setup, as you can see. So the first year all the mulch are very great. We applied it under the row in 60 centimeter width with 10 centimeter thickness. We have noticed that below 10 centimeters of thickness, the mulches are not effective in weed control. The degradation is too fast. So mulch should applied at minimum 10 centimeter thick. And for economic reason, because the cost is high, we can reduce the width at 40 centimeters. The idea is to cover the row, and the width of the row also depends on the work you do in the intra-row area. What are we following in this trial? So we have some parameters to follow to measure the weed. So we do weed cover with some apps. We also did identification of flora to assess if the exogenous mulch can grow some species that were not initially present on the plot. We also assess the water status of the soil with measurement of the temperature above the mulch, with it's a water status of the plant, sorry, with the following of apex growth and the plant water stress. We follow the plant status, the nitrogen in the plants. We made some berry analysis to assess berry quality, yield and vigor. And finally, we measured parameters on soil, soil humidity, texture, structure of the soil, and some indicator of biodiversity as worms and microorganisms. So some results first on weeds. So in this trial, we had two climatic contexts. We had a Mediterranean context with high temperature and low precipitation. And we had a second climatic context, which is a temperate context with high precipitation, cold winter and hot summer. So the pressure of weeds is different according to the context. So for the Mediterranean context, as you can see on this graph, it's a bit small, but the idea is to show you that in yellow you have no intervention treatment. So that means there is no intervention of weeding at all below the row. In light green, it's the control mechanical weeding. All the mulches are below the weed cover of no intervention and mechanical weeding, with some variation during the year, depending on the pressure. And for the temperate context, it's a bit more complicated. So the no intervention is very high in weed cover. So we have reached like 70% of weed cover below the row. And for the mulches, it's really depending on the material used. But what you can see is that the evolution during the 3 year. So we put the mulches in autumn 2020 and we follow it until autumn 2024. But as you can see, the evolution, the weed cover is increasing with the years as fast as the mulch is degrading. Some pictures, because pictures are more easy to understand sometimes. So some example here, it's a cellulose felt. So the cellulose felt, the first year is the picture at the left. So it's great, and it's the degradation is fast. 3 years after, on the picture at the right, the felt is totally degraded. This was in temperate context. In Mediterranean context, we managed to keep the felt during 3 years in a good state. This one is a cellulose felt, so cellulose is more fast to be degraded than the linen felt. Wood chips. Wood chips have a good control on weeds, so they can be kept for 3 years sin problem. As you can see on this picture, so their degradation is slower, and they have a good impermeability of weeds, because each chips is stick to another one, so it creates a permeable part under the row. Green wastes are effective as well, but what we observe during this trial is that green wastes have a very quick degradation, so they cannot be used in a strategy of 3 years. So I put the mulch and I wait for 3 years, it's not possible. So the advice is to apply annually green waste. It can last 2 years, but no more. And finally, miscanthus straw. Miscanthus straw has shown very good results. This one was tested in Mediterranean context, so after 3 years and more, we still have some straw under the row and not so much weeds. So for the miscanthus, the results are really promising. So as I said, the effect on weeds is variable and depends on climatic context. In a dry climate, mulch are a bit more effective than a wet climate. It's also depends on the type of soil and fertility of the soil. If the soil is degrading more or less faster the mulches. It's really depending on the type of mulch. If it provides a good coverage, good permeability to weeds, its speed degradation. It's depending on the quantity of mulch applied. Some mulch can be applied only once for 3 years, some need to be annually applied, some can last more than 3 years. So we have as many answers as we have material. And we have no impact on weed performance. So we have no penalty of yield, of vigor, grape quality are the same. So it's a good point for that. But some caution points on the use of mulches for weed control. So in some contexts, it needs to be stable in windy plots, for example. And this is very slow to do, so it can increase work time for implementation. Be careful also of wild game and rodents that can cause damage, as you can see on the picture on the top. Enterro management must be carried out carefully. You have to adjust the width of the mulch under the row to the width of the enterro tools so as not to remove or to degrade the mulch when you are working the soil or mowing. And we observe that weeds contamination often comes from the enterro area and not from the row area. So yeah, and the last one, pay attention to the location of the vine in the mulch, as weed can grow in the gaps. For example, for the felts and for the bull, we have some spaces, as you can see on the picture, just to have a place for the vine plant to grow. And in these spaces, weeds grow too. So as small as the spaces, the better. Other results on soil quality, we have not measured soil erosion, but in some slope plots we have noticed that we have less soil at the end of the plot on the line with mulches, so it can reduce erosion. And mulches have also the good impact on soil moisture, and it can improve soil humidity. So we made some measurement on soil humidity with a sensor. And as you can see on the graph in the left, in a very dry vintage, it was in 2022, it was very, very dry in France. So we have a very low content of water in the soil. So on average 4% of water in the soil. So it's very low. But some mulches can keep more humidity. For example, the oyster shell in this vintage has shown a great result because it can have humidity, 8% of humidity in comparison to the chemical, the bare salt that was at 3%, so it's great. And in another vintage that was dry but not as dry as 2022, we have seen great significant difference between the type of mulch used. So the mulch of oyster shell was 6 times wetter than the bare soil. Green waste are very more wet. To precise, in this year we've made an annual addition of green waste, so it's new green waste. But as I said, green waste need to be applied annually, so this effect on humidity can be shown each year. In contrary, vegetal felt is not so good in keeping soil moisture. In this trial, we didn't have miscanthus, but I have another trial with miscanthus, and miscanthus also show great results in keeping higher humidity than bare soil. Mulch has also an impact on temperature, so it can buffer temperature fluctuation. And we have observed during summer up to 3 degrees difference between a bare soil and mulches, every type of mulches. So in this graph, it's a variation during the day between 3 days. So you can see in blue, the bare soil, that the temperature are much more fluctuating and are higher than the mulches, the soil covered with mulches. And last one on soil quality, mulches can also increase organic matter, so it depends on the material used. Of course, organic shells are not increasing organic matter, but green waste and Other can really increase a lot the organic matter. It can increase pH. For example, the oyster shell will increase pH, so it's interesting in the case of acid plots. The mulches can increase microbiological biomass, and they also increase the abundance of earthworms. So we have measured the number of earthworms at the beginning of the trial, and we have also measured 3 years later. And as you can see in this graph, so at the initial state of the plot, we have less than 250 earthworm per square meter, sorry. And according to the mulch, we can double the quantity of earthworm with a preference of organic matter, for example, wood chips or green waste. They didn't like oyster shell, the earthworm. It's not so good for them. In a conclusion, the efficacy of mulch is really variable according to the type of material used, but can globally control weeds for a period of 3 years or more or less, depending for green waste. It allows to stop managing the underrow area and stop using herbicides. The degradation rates of the mulches and their lifespan are variable, but they can buffer soil temperature, they can maintain soil humidity in summer, provide organic matter, and can increase soil biological activity. But there is a but, it's a very high cost. So I put as an example in the table the annual cost of chemical weeding in France. So it's a cost for France. It's 3,000 euros per hectare per year. In comparison, mechanical weeding is 4,500. And the cellulose felts are between 5,000 and 6,000 per hectare. Only the cost of the material. I didn't count here the labor costs of implementation and the transport costs. Miscanthus is an average of 4,000 per hectare, and it's more economic. And green waste and oyster shell, for now, it's there is no cost for this. It's a circular economy. It's a valorization of waste. So that's why their interest is good and high, because implementation is very slow and difficult. So if we can use some free products or very cheap products, it's more interesting than to buy a wood chip, for example. But be careful, because the mulch resource is not always available. Oyster shell is not existing everywhere, as well as miscanthus. So it's really depending on where you are. But locally, there is probably a lot of possible things to do. The installation is for now manual. It's not yet mechanized. We have conducted some trial of a sprayer to try to put green waste below the row. It can work, but it's very slow. So for the moment, this is a big break for mulch installation. Also, mulches can introduce grapevine trunk disease fungus, particularly the one made with woods. It's not really a problem, but you may know when you put something on your plot, maybe you will increase the inoculum of grapevine trunk disease fungus. And the interrow really need to be carefully managed, because most of the problems appear because of the work in the interrow. And that's it. I have finished. Thank you for your attention. And if you have any question, I will be happy to answer it.
Thank you very much, Fanny. We do have two questions here for you. So which apps do you use for the weed cover assessment?
Yeah, it's an old one. It doesn't exist anymore, but there is several apps that can detect chlorophylla. We use now one that it's called canopy cover, I think. There is several, but it's good. So I do twice, in fact. I use apps and I also do it visually.
Okay, thank you, Fanny. And the second question is, have you seen any effect on soil moisture in Mediterranean conditions?
No, because in Mediterranean context, we didn't measure it. So I don't have any results in this context. It's the next trials.
Okay, thank you, Fanny. That's it for now. We might come back to you with other questions. I just would like to come back to Matt's presentation because we have two extra questions. So, do you have trials data to show a decline in weed numbers, grass weeds, with a living mulch system? And are trials still being carried out?
So I will put into the chat, there's a final report that has the detail of the weed results from the trials. There's a final report. I'll share that with you. You can go through it. And in terms of ongoing trials, the official trials are finished. They ran for 4 years in total, but I'm working independently with other farmers who are still using the systems on their farms. So in the technical guide that I believe Camille has put it in the chat, there's a case study of a farmer called Matt England. He's over in Norfolk, and so we're working with him as he continues to trial as well on his farm.
Okay, thank you. And second question, is there any allelopathic effect on the cash crop of rye mulch during residue decomposition?
Yeah, we didn't look at this in the system, so I can't say for sure. I know that in undersowing sort of 1 year approaches, so not quite living mulches, using something like buckwheat has this allelopathic function against what we call in the UK couch grass. So there are some options for that, but the mixtures that were used were clovers, and so we didn't see this, but we didn't test for it, so it's unsure on that front. But there's on the agroecology website, there's quite a few resources on allelopathy, so it's worth looking at that as well.
Okay, thank you. And last question, which is the optimal method for terminating the cover crop to avoid regrowth?
So it depends on your system, really. In the trials we did, the farmers went in the year 3, they went into a herbal ley. And so they had that herbal ley running as a fertility building block in their rotation. When they went back to production, they were ploughing this in. So that is kind of the standard low input approach, is that you go back to ploughing in your rotation. If you're just working in a low input system and you're not using it as a fertility field building block, you need to terminate it in another way, which again is really back to ploughing again. So I think the cost of the seed is not that significant, but it can be quite high. So really it's about where you put it in the rotation as to how you manage it. In a very conventional system, someone may be spraying glyphosate on that, but that's not something we'd recommend. And it sort of goes against trying to reduce these applications in season by using these approaches. So yeah, ploughing really is the best thing. What you do find is that the vigor of a clover-based mulch, when you get into year 3, the clover's vigor reduces. So you could have perennial weed issues if that population abundance had increased. Then you could see this real transition. So it's not like going into such a traditional direct drilled circumstance. And again, a bit of ploughing in the rotation, it's not going to do too much damage, and it will get rid of that cover crop.
Okay, thank you very much, Matt. So as Matt pointed out, the Living Mulch Technical Guide has been put on by Camille on the chat section, so you can find the link there. So now we will go to Yanis for his presentation.
And I will share.
Yeah. So can
Okay.
you? Okay.
Well, hello. I will present now some results from the first growing season in the Greek living labs established in Greece, in the two living labs of the GOOD projects, concerning the combined effects of cover cropping and agroecological weed management treatments on wheat flora and crop yield in the wheat crop in the first living lab and grapes in the second living lab, the perennial crop. We can proceed to the next slide. And the next one, to tell you a bit about the experimental design. In the annual crops of the project, we follow a common approach as in this living lab with winter wheat. We set up the experiments according to the split plot arrangement with a main plot factor as the cover crop, and weed control treatments, the agroecological weed management treatments, are tested in the subplots of the experiment with a randomized complete block design with 3 replications. The 4 cover crop treatments are Trifolium alexandrinum monoculture, the legume cover crop, Lolium perenne, a grass cover crop, their mixture, and of course a non-cover crop control. And there are 4 subplots like the untreated control first, a selective herbicide treatment at the full recommended rate and at a reduced at the minimum recommended rate, mechanical weeding, and the implementation of the fall seedbed practice. We can continue. This is the experimental design for the conventional site. The experimental layout results in a total of 60 experimental units in total this first growing season. And here are some first results regarding the active growth stage of the cover crop, where the biomass of the cover crop on the left charts shows that the mixture of the 2 cover crop species, Lolium perenne and Trifolium alexandrinum, is superior in terms of biomass production by around 70% compared to Trifolium alexandrinum alone, and is also greater than the sole Lolium perenne cover crop. And the cover crop mixture leads to a greater weed density and biomass as well in the cover crop compared to monocultures, and of course compared to the untreated control. And the superior biomass production in the mixture of cover crop plots may be attributed to the complementarity of resources of these 2 cover crops, because the one is grass and the other one is a legume cover crop, so maybe these species exhibit a complementarity of resource use. And we can now continue with the measurements on the cash crop, which is winter wheat, to see first the analysis of variance. That the 2 parameters I'm presenting now is the wheat biomass in the main crop, the cash crop, and the grain yield as well. Both parameters were influenced at a significant level from the cover crop selection and the weed control treatments as well, but also from their interaction, and that's why I'm presenting interaction charts that show the interactions between the 2 factors. Therefore, the combined effects of these 2 experiment factors on the measured parameters that show us in the next slide that with biomass was suppressed most when in the subplots where herbicide was applied at the maximum application rate and the minimum and the reduced recommended application rate, the minimum application rate as well, in the main plots where the mixture of the two cover crops had been planted and then terminated. I should define now that the cover crops, the residues are not on the soil surface. The residues have been incorporated into the soil because in Greece we do not implement a zero tillage system. We implemented conventional one with conventional seedbed preparation, and that wheat biomass was maximum in untreated plots and in plots where Trifolium alexandrinum alone was a cover crop and no other wheat control measure was implemented. Next slide with the grain yield. With the grain yield, we can see that the combinations of cover crop and herbicides or mechanical weeding that resulted in the lowest wheat biomass values, these were the interactions that were the highest yielding. And then we can continue with the organic, with a brief representation of the organic farming system, where the approach is similar. Next slide, please. Okay. Where the approach is similar, with the only difference that there are four weed management treatments here. Like we don't have any herbicide application, it is organic management, but we keep full seed bed and mechanical weeding, and we add another treatment, a stale seed bed with pelargonic acid. Like in this approach, we after seedbed preparation, we let the weeds grow about some interval of some weeks to exploit the rainfalls, and then after weed emergence we spray the field with pelargonic acid, a non-selective natural herbicide to control weeds. And this experimental design, this experimental layout resulted in a total of, next slide please, in a total of 36 experimental units. And the results in the next slide show that the data collection, okay, I can tell you that Avena sterilis, sterilote, wild mustard, Veronica enderifolia, and Gallium aparine were the dominant weeds in this site as well as in the conventional site. We measured again wheat biomass and winter grain yield, and we had already measured cover crop biomass before termination as well as in the conventional site. And then in the next slide, the results that we observed a similar result regarding the biomass production of the cover crops and their weed suppressive ability. The mixture of the two cover crop species was superior to monocultures again, and this was also presented in the cash crop of winter wheat in the next slide, where there are significant effects of cover crops, weed control treatments, and their integrated effects are significant on the wheat biomass and the yield of durum wheat. Another one, where here it is important to notice that the combinations of the mixture of cover crops along with mechanical weeding and full seed bed and stale seed bed, where this interaction showed a very good efficacy, and this is notable because we do not expect to see that, because the concepts of cover cropping and full seed bed or stale seed bed are a bit opposite, but maybe there was a synergy that was achieved. We can give more explanation on the discussion section after I finish. Again, the monoculture of the clover cover crop, along with untreated control, resulted in the highest biomass production. And in the next slide, these were the lowest yielding interactions, but the combination of cover cropping with most of the treatments except of the untreated control resulted in acceptable yields that were typical of the Greek farming systems. Next slide, please. Thank you. Some pictures from our experimental field. On the left, bottom left, we can see a Sinapis arvensis plant that is much bigger and infesting the cover crop monoculture of Trifolium alexandrinum. And then in the center is Lolium perenne cover crop and the mixture on the bottom right. And then we continue with more pictures with the next living lab. And these are from the treatments, from the agroecological weed management treatments, herbicide application on the conventional side, fall seed bed, mechanical weeding, untreated control infested with a lot of weeds in the early growth stages. Next slide. And then we can continue with the other cropping system, the perennial one, where in the conventional system we have 7 treatments implemented in the interrows of the areas between the rows of vines. In the conventional system we have untreated control, veg cover crop, oat cover crop, their mixture oat plus veg, herbicide application at recommended and minimum recommended rate, and mowing. And organic farming system we have untreated control, veg and oat, the same cover crops, their mixture, mowing, and some rotary tilling. And then we continue. We explained that in the first year of the trial, we implemented treatments between the rows. Treatments between the vines in the rows will be implemented in the second and third year of our trials. And we do not have any yield measurements this first year because we had to select the best treatments to build up our trial design for the second and third years that will be repeated. Next slide, please. Again, we have as data collection the cover crop biomass with biomass before termination, and I have some data also from the summer weeds after cover crop termination and some bullet points. We can proceed with the results, where the B species mixture achieved a slight bigger biomass production than oat monoculture, but significantly higher biomass than veg monoculture. And there was a descending order for wheat biomass, with no cover cropping having the higher biomass during the active growth stage of the cover crop. Then is veg, then is oat cover crop, and the most effective cover crop in terms of weed suppression was the mixture of the two species. And then we can continue with the organic system, where the results are quite similar. And so I will not repeat just the similar results. We can continue with the next slide, where are some pictures from the vineyard in Nemea region. On bottom left is the veg monoculture, on the center is Avena sativa, oat monoculture, and on the bottom right is the mixture of the two species, which is very common in Greece, and some pictures from the termination of the cover crops by one or two flail mowing passes to kill the cover crops, and then continue with measurements on the summer weeds that emerged later in the season, around July and August. We can continue. Like from the summer weeds, there was an efficacy of only the herbicide treatments on summer weeds, because we had a very tricky and troublesome weed flora with Convolvulus arvensis, field bindweed, and Kinan humacutum, which are two perennial climbing vines, climbing weeds that are perennials, and it's almost impossible to achieve sufficient control without herbicide application. And we, in both organic and conventional side, with only cover cropping, the mulches of the cover crop suppressed these weeds by only around 50%. And then as also mowing and pelargonic acid treatments, and then the weeds exhibited a significant regrowth. So it was very tricky, the wheat flora, and we will continue in the next years to design something else to achieve a good control. But we can now continue with the conclusions of this work on the next slide. Like that, cover crop diversity expressed by establishment of mixture tends to improve with suppression from these first year preliminary results. The combination of cover crop establishment and other non-chemical cultural weed management practices, as the mechanical weed control or the false bed, can achieve the optimal weed suppression and thus the highest yields. Uh, Another finding is that the establishment of the cover crop can be combined with herbicide application both at recommended and reduced rates. And maybe this is because the cover crop mulches delay the emergence of weeds and enable the farmer to conduct the operation, so either it is herbicide application or a mechanical weed control, at a more suitable time when weeds are earlier growth stages and are very sensitive to weed control treatments. In any case, the results of the first years and the differences build the basis to test more combinations of alternative agroecological weed management practices, and they should be tested in more soil climatic conditions and environments in the next years of the project. Thank you very much for your attention.
Thank you, Yanis. We don't have any questions that have come through yet. So I suggest we carry on with Maria's presentation. Camille will be sharing her presentation.
Hello, everyone. Well, first of all, apologies because my camera is not working, so you cannot see me, but I hope you can hear me. Well, I'm going to present what we are doing in the GOOD project about the inoculation of the cover crop seeds. Well, I have to say that I'm an agronomist and I work in Cicitex, which is a regional research center on the west side of Spain. Next slide, please. Yes, well, as Alexandros have mentioned before, we have using the cover crop as cultural practice in all our living labs in 16 living labs in different bioclimatic regions in Europe. And all of them are following more or less the same practices in order to compare the effects of different solutions. We are working with perennials and also with annual crops, and showing cover crops of different species. Next slide. Well, the soil, well, the seed inoculation techniques is part of the activities that are being carried out in the Work Package 4 of GOOD, focus on the improvement of the performance of crops and also cover crops, and trying to increase the competitive availability against weeds of these cover crops. The colleagues from the University of Pisa are in charge of this particular activity about inoculation of cover crops with arbuscular mycorrhizal fungi that we have found in all the soils in each living lab in the project. Next one. Well, why we are inoculating the seeds of the cover crops? Well, because there are some benefits of seed inoculation with these microorganisms. First of all, because arbuscular mycorrhizal fungi are symbionts that have a key function in the networks below ground and above ground, and has a specific association with the roots of most plant families. And they can influence not only the soil fertility, but also other key aspects like plant nutrition, because they improve the nutrient uptake, especially phosphorus. They increase the diversity, soil diversity and productivity of plants, and the plant resistance to biotic and abiotic stresses, especially against diseases and drought. They also have positive effects on seed germination, because they accelerate the seed germination in many species, and they have also an effect on the rootlets growth in the earliest stages of the roots growth. And this is favoring the cover crop establishment, the cover crop rapid soil coverage, and thus, smoothing the weeds. And they could also enhance the yield of the main crop in our living lab, so that we are also, for the next experimentation year, we are thinking and inoculate one main crop, the rye, in this case, the rye crop that is being tested in the Latvian living lab. Next one. Well, as I mentioned, in each living lab, we have tested several, at least 3 different cover crops in the first experimentation year. And then we have selected one, the best one, for the second and the third year. Each living lab have selected the best one in terms of weed suppression, management, and adaptability. But it is also important to think that the cover crop should be suitable to be inoculated, because not all crops are have a very good performance of the symbiotic relationships, and we should avoid in this case the use of allelopathic plants or species. Some legumes like lupins and also the brassica species do not perform well in terms of inoculation, but others, like most of legumes, many grasses, and other broadleaf species are among the best options. So you can see that in the different good living labs for the second and the third experimentation year, we are using different species, mainly legumes and grasses, but there are others like Phacelia, Thanacetifolia, or some brassicas in mixtures with other species that are suitable for the inoculation. 7 of the cover crops are monospecifics, and the other are mixtures. Next one, please. Well, the process that we are following in the project is that every living lab have to show the selected cover crop without inoculation and inoculated, both in order to compare the effects of the inoculation. And the steps are the following. First of all, the PISA team, our colleagues from PISA, have identified the native arbuscular mycorrhizal fungi taxa from 7 European countries based on the soil moistures that every living lab have sent to them. Then once we have the native microorganisms identified, they have produced bigger amounts of this fungi for 14 living labs by using a specific technique with mycotrophic host plants that has a very high potential to foster the symbiotic relationships. Once we have this inocula propagated in enough quantities, we proceed to the seed inoculation of the different cover crops in the different living labs, applying the spores or the mycelium directly to seeds, following a specific protocol that have been developed by our colleagues in PISA and share with all the living labs. And this protocol is also available for anyone who want to consult it, because it is one of the deliverables of the GOOD project. And after inoculating the seeds of the cover crop, we proceed to the sow. And at this moment, we are assessing the effects of this inoculation at field. One of the parameters that will be assessed is the mycorrhizal inoculum potential. It means how the fungi, these mycorrhizal microorganisms are affecting the root growth. And on the other hand, we will assess another plant parameters such as biomass, coverage, and so on, comparing the non-inoculated and the inoculated cover crops to see if we finally achieve differences in the weed suppression. Next one. Well, these are some examples about the native fungi found in 3 Spanish living labs, in a cherry orchard in Extremadura region, in a rice plot, and also in the orchard of apple and grapes in the north of Spain, in Galicia. And we have a very high diversity of spore morphotypes. It means, species, different species. Next one. Here you can see the different spore morphotypes found by our colleagues in the different living labs, and it gives an idea about the diversity of the species found in each living lab. And we have found from 4 to 17 different species. The best one have been the Mediterranean living labs, especially Italy or Spain, but we have found enough families or combination of native fungi to proceed with the multiplication of the inocula and to get a successful inoculation process. Next one. Well, once we have identified the best or more relevant species, the multiplication, the production of the inocula for the seeds have been done using these three species that are that have a very well performance in terms of root colonization, spore production, and high quality of the production of the mycelia. And then the spores and the mycelia produced in the roots of these three species grown in plots, Bithia villosa, Cichorinum tibus, and Medicago sativa. Then we use the roots to make suitable inocula to be used with the seeds, following the protocols that our colleagues are developed. Next one. Here you can see the effects on the seed germination in two species, in Bithia faba and Triticundurum. The control and the protocols have been developed using different combinations of seeds and inocula in 11 crop species. These are two of them. As you can see, the results after 2 days after sowing, you can see that the germination or seeds germinates earlier in the inoculated case, and also the elongation of the rootlets are higher when we use the inocula, when the inocula is present. Next one. And now at field level, the second stage of the assessment, we are trying to assess the mycorrhizal colonization in the roots in the different living labs. We are developing this work. We don't have any conclusions or results yet, because we are growing the crops and taking measurements, but we could see the first visual effects of the inoculation in the roots of the different cover crops, and also in the growth of the inoculating and non-inoculating cover crops. My colleagues from different living labs told me that the effects are higher in the conventional farms in a general way, because the inocula are increasing the diversity of microorganisms in the soil. Next one. Yes, this is another example in Medicago truncatula. Is a cover crop used in Sardinia, in Italia. And here you can see how the fungi are performing and developing the arbuscules and the vesicles in the roots. So it is very, very clear action and symbiotic effect. Next one. And these are some samples from the last week in a cherry orchard in Spain. These are clover crop, Trifolium subterraneum. And you can see here how the inoculated plants have a higher growth and height, and also a better root growth and rootlets development. As I said, we don't have any measurement so far, that we are now well taking samples to see the biomass, and all living labs are taking samples of roots in the different cover crops, and also in the different places where other practices for weed control are being applied, in order to see what happens when we apply additional or a combination of different practices, and what's happening with the mycorrhizal potential, inocular potential. Next one. Well, you can say, or you can consult more information about this practice. We have produced 3 practice abstracts that I am not sure if they are now in the website, but if not, they will be soon. And well, they are focused on the inoculation, seeds procedure, how to do it, how to select the right or the proper main crop to be inoculated, and other general questions and practical questions. And I think that's all. As I mentioned, I don't have any results about the mycorrhizal potential or the effects on the plants, because we are now measuring these all parameters in the soil, in the roots, and in the plants. But we will have soon some results after the summer. Thank you so much. If you have any question.
Thank you very much, Maria. We don't have any questions. If anyone wants to write questions, there's still time. If not, we will have to say that it's the end of this webinar. And thank you very much to all our speakers and to all your participation to this webinar. So for your information, the replay will be available on the IFV website as from the 5th of May, about noon. So if there are no more questions, and I don't see any, if
Thank you a
Camille,
lot,
you want
Emma.
to conclude.
Yeah, no, that's fine. You closed it well, so you just 1 more minute in case you want to write last question, but I think that's it. So you have just a reminder in the chat some links to Agroecology and to Good project, and you can also have a look on OPER8 website, which is also providing some more information and some additional information. So I will just add it right now to everyone. Here we go. You have the link in the chat. Thanks a lot, everyone. I think no more questions.
Thank you very much. Have a nice day.
Thanks for joining.
Thank you very much.
Thank you, everybody.
Thank you. Bye bye.